G'day, welcome back. May 2015 SL Maths, Paper 1, Time Zone 1. We are on the downhill run. Question 9, nearly there. Calculus, finally, you've been waiting for it because you know you can nail this. It's very predictable what they're going to ask you. Just go through the motions, do it, nail it, get the marks. Very good. Here we go. A function f has its derivative given by f dash of x equals 3x squared minus 2kx minus 9. Excellent. Find the second derivative. Well, that should be pretty easy. It's just the derivative of what we see in front of us. So the derivative of 3x squared is 6x. The derivative of negative 2kx, that's x to the power of 1, so it just becomes negative 2k. And of course, the derivative of negative 9 is 0. So that's it. We're done. 2 marks. Very easy. Let's move on. The graph of f has a point of inflection when x equals 1. What does a point of inflection mean? Second derivative is equal to 0, and so you can see that they've led you into it, second derivative there, then they're asking about it, and there's a sign change, but we can just go with the second derivative equaling 0 for now when x equals 1. So f dash dash of 1 is going to give me 6 minus 2k. I just sub 1 in for x, and we know that has to equal 0. Well, that's very easy to see that k equals 3. Add 2k, divide by 2, you're there. Find f dash of negative 2. Well, here we've got f dash of x. We now know what value k is. So this is actually 3x squared. K is 3, so it's minus 6k. Whoa, that's a bit wonky. Try that again. Minus 6x minus 9. That's what we have there. That's f dash of x now. When k equals 3, that negative 2 by 3 will become negative 6. That's good. F dash of negative 2 is going to equal 3 by negative 2 squared minus 6 by negative 2 minus 9. Again, excuse my working here. You would show you're working down the page, not going across like that. It's a little bit naughty, but just trying to keep you so you can see the questions. So we've got that there. Negative 2 squared is 4 by 3, so that's going to be 12. Negative 6 by negative 2 plus 12 minus 9. 24 minus 9 equals 15. Find the equation of the tangent to the curve at f of f at negative 2, 1. Giving an answer in the form y equals ax plus b. What are the two things you need to find the equation of a tangent? You need to know the gradient and you need to know the point. They have given us the point, and f dash of negative 2, they've given us the gradient. So the gradient is 15. So therefore we've got, they want it in that form, but I'm going to go with y minus y1, which is 1. Equals m, the gradient 15, x minus, and x1 is negative 2. You could just use y equals mx plus c and sub in negative 2 and 1, it would work as well. Either way, we're going to get the same answer. This is going to be 15x minus negative 2 becomes plus 2, so that's plus 30 when I multiply it by the 15. So y equals 15x, subtracting 1, add 1, 15x plus 31. That's your working for D. A little box drawn around it there. Given that f dash of negative 1 equals 0, explain why the graph f has a local maximum at x equals negative 1. Alright, so f dash of x, 3x squared minus 6x minus 9. We know that it's equal to 0 when x equals 1. We can check that. 3 or negative 1, 3 minus 6 by negative 1 would be plus 6. So 3 plus 6 is 9 minus 9, 0. That all checks out. What are the two ways we could do this? I can just find the second derivative at negative 1. What is the second derivative when I sub in negative 1? We found k equals 3. So it's 6x minus 6. So we're going to have 6 by negative 1. Minus 6, which is negative 6 minus 6, negative 12. Therefore, since f dash x equals 0, sorry, f dash negative 1 equals 0. And the second derivative at negative 1 is less than 0, it's negative. That means we have a local maximum. Of course, you could have just done this using the first derivative test as well. Here we've got f dash of a number less than 1. Here's less than negative 1. Here's f dash of negative 1 and f dash of a number bigger than negative 1. So it's really just like a little sign diagram. So what's a number local to that? Well, let's just put in negative 2, see how that works out. Negative 2, that's going to be 12 plus 12, 24 minus 9. Whew, it's going to be positive, isn't it? 0. Now, maybe you can't just get away with showing positive because you might just cheat and guess that. So maybe you actually want to show f dash of negative 2 and actually work it out. What did we say it was? We said it was 12 and 12. 24 minus 9 is 15. Oh, well, we already figured that one out, didn't we? So yes, we got that right. And let's just sub in 0. F dash of 0 is negative because it's indeed negative 9. Therefore, a local max. First derivative test, second derivative test, either one works fine. Nailed it. Done our calculus question. One question to go. Let's see you in question 10. Cheers.